Hello guys, good evening. So have you guys gone through the problems? Ramya, I have seen your
Yes,
problem.
sir.
Yeah, I will discuss them. Other than that,
Yes, sir. Sir, actually,
yeah,
shear force, bending moment, and reaction diagrams, it is easy to draw, sir. But the moving loads, when it is given on moving loads, it is difficult, sir.
that we'll discuss. As of now, if you
Okay,
can
sir.
draw the deflector shape, that's completely fine.
Yes, sir.
Okay, now as you guys have already, as we have already gone through this ILDs for either shear force or reactions or bending moment diagrams, let's just see the application of them today. Just for that, let us consider a simply supported beam, and then let us try to apply whatever we have known. So imagine there is some point around here. See, it's not a hinge, it's just a point. Let us say 2 meter and 3 meter. So what is the ILD for shear force at that point? C. As you guys remember, I think
The right side will be a triangle and left side will be a
angle. And what about the slope here? 1 divided by total length. Total length is 5. What about the slope here? 1 divided by 5. And then this ordinate will be 3 by 5, 0 0.6, 0 0.4, positive shear force and negative shear force, right? I don't think you guys have doubt on this. Similarly, let me draw ILD for bending moment. So what about this distance? Can you guys tell me? AB by L. A means both spans distance 2. Opposite distance 3 divided by total length is 5. So if you solve this, you will get it is around 6 by 5, 1.2.
sir.
What about this slope? Opposite distance by total length. What is opposite distance? 3. Total length is 5. That will be equal to 0.6. What about this slope? Opposite distance 2. So 2 by 5. That will be equal to 0.4. Right? Now, let's discuss this in general. Okay. Let us assume that a point load, let us say 10 kilonewton, is moving over the beam. Now, as of now, let us concentrate at point C. Let us say, suppose, forget about moving loads and everything. If you want to design this beam, let us say if you want to design this simply supported beam, what are the parameters that we require in general? I hope you guys might have come across design of RCC or design of steel structures, you guys might have. So what you can or what you should obtain is that you have to find out what is the maximum bending moment that can act on the beam due to the loads, and for that maximum bending moment you will design it, or you need to find what is the design shear force. So for that we have to find out what is the maximum bending moment and also maximum shear force. That means irrespective of the loads and irrespective of their positions, we have to obtain what are the maximum values that are possible on the beam. For those maximum values, we should be able to design it. So as of now, just for the sake of it, I am talking about a point C. That means if we are talking about point C, at point C, if 10 kilonewton load is moving, let us say either from left to right or from left to right. If only one load is moving, it doesn't matter. Either it will move from right to left or it move from left to right. Why? Because as there is only single load, we have to take only single ordinate. So at point C, what I am interested in to see is that what is the maximum shear force. In particular, if I want to see what is the maximum positive shear force or what is the maximum negative shear force, or I am interested in finding the maximum bending moment, right? So if I can able to find out these values, then I can say that or I will design this entire beam for these values. Now look at this ILD diagram. By looking at this diagram, can you identify somehow that where you can get the maximum shear force? From the diagram itself, if you are looking at it, and can you tell me where the maximum value can be possible?
At C, sir.
Not exactly, even though we'll talk about at C, but we'll just say just to the immediate to the right also. Why? Because if, as we know that load into ordinate, isn't it? Wherever, yes, sorry, my screen is turning. Wherever the ordinate is high, at that point we will have the maximum value. So as I look into this diagram, we are having positive shear force values, we are having the negative shear force values. If I look into the positive shear force diagram, where is the maximum ordinate that is happening? This is the maximum ordinate that is possible. So if I want the maximum shear force, or if I want the maximum positive shear force, where I should place my load? I should place very much nearer to the point C. So what is the maximum positive shear force? By looking at this diagram, I can say, so to get the maximum shear force at point C, positive shear force, I will place my 10 kilonewton very, very nearer to the C. Now, what about the maximum positive shear force? What is the magnitude of load? 10.
10 into 0.6.
What is the ordinate? 0.6. That will be is equal to 6 kilonewton. So, if a load is moving over this beam, what is the maximum positive shear force that can possible at point C? 6 kilonewton. Similarly, what is the negative shear force? As you can directly looking at it, it is also very much clearer to the point C. So for negative shear force, we have to take the negative ordinate value. What is the total load? 10. And what is the ordinate negative ordinate? 0.4. That will be equal to minus 4 kilonewton, isn't it? So if it is a single point load, directly we can apply, isn't it? Wherever the ordinate is maximum, you place the load at that point, and then you can say that that is the maximum value. As of now, any doubt in finding the maximum positive shear force and maximum negative shear force?
No, sir.
No, right? Now,
Yes.
let us come to the maximum bending moment. Again, if you look into this diagram, where you are having the maximum ordinate?
1.2 at the center.
1.2, that too at point C.
Point C.
And one more point we have to observe is that in the entire beam, we are having only the positive bending moment, isn't it? Is there any negative ordinate values in this diagram? No. But in the shear force, we are having positive ordinate values as well as negative ordinate values. But in the bending moment, for this case, specifically, I can say that only positive ordinate values are there. So what is the total load? If I want to find out the maximum bending moment, as I know that maximum ordinate is at point C, that's why I should place my load at point C. So for getting the maximum bending moment again, what is the total load? 10 into what is the ordinate? 1.2. That will be equal to how much? 12. What is the unit here? That I should represent. What is the unit I should represent here? Load I have taken in kilonewton.
Kilonewton meter, sir.
Is it meter exactly?
Yes, sir.
For shear force also we are taking load
Yes,
into
sir.
ordinate. For bending moment also we are taking load into ordinate. Then how come the both will come different units? Is my question right? For maximum shear force also we are taking load into ordinate, isn't it? For bending moment also we are taking load into ordinate. Then how come they both are in different units? You can see what is the ordinate of 0.6. What is the, if you are writing 1 by L, what is the unit here? 1 by M. 1 by M into you are multiplying it again length. That means 1 by M into again you are multiplying the distance. MM gets cancelled. So these ordinates have no units. So if you are talking ideally for shear force diagram, the ordinates you are obtaining, it don't have any units. But if you are talking about bending moment, whatever the unit of 2 meter, whatever the unit of 3 meter divided by what is the unit of 5 meter, meter gets cancelled, that you will get equal to M. So what is the unit of ordinates for yield of bending moment? Meters. What is the unit of ordinate for shear force? No units. That's why for shear force, you will directly get the unit of load. For a bending moment, you will get the unit of load times the unit of the ILD. Here ILD is M, Newton meter. As of now, clear?
Yes, sir. Yes, sir.
Clear, right? There is no ambiguity, isn't it? It's crystal clear. One simple thing.
Yes.
Wherever you are having the maximum ordinates, there you have to place the load, and that's it. That's what your maximum value. Even though it's such a simple case, isn't it? 10 kilonewton or any load. But if combination of loads are moving over the beam or over the structures, it's not like in reality every moving load is of typically represented as a single unit load. It's not. If a bike is moving, you can say that two wheels will roll over the beam. That means you can idealize them as a 2-point loads, isn't it? If I take a bike, I can say that I can idealize them as a 2-point load. If a car is moving, even if you talk about in a 2-dimensional 2-point loads, but if you are talking about a truck, so for different types of vehicles, different types of combination of loads are possible. So that's why for different possibility of loads, we have to try to get the conditions to get the maximum corresponding values. As of now, let's just keep this aside and then let us talk about first for UDL case, and then we'll talk about the combination of the loads later on. Again, I am considering the same beam. Now, instead of point load, let us imagine UDL load is moving over the beam. Five kilonewton per meter, 3 meter. Let us assume this, okay? Right now, I'm not talking about any special type of case, but I'm gonna discuss you for this load only. 5 kilonewton per meter over a length of 3 meter. Now, again, what I should get? Again, I should get the maximum positive shear force, maximum negative shear force, and then maximum bending moment. Can you identify now what is the difference between this case and the previous case? What is the difference? Can you please identify? In previous case, what we have spoke about? A single
Point.
If it is a single load, we are gonna identify it as a single ordinate. But here a UDL load is moving over the beam. Then how can I simplify this? Or imagine, before that, let us say there is a function here, and I want to find out the area under this curve. Can you tell me how can I find it out?
Integration.
Integration, right? So how can I apply that integration? Can you just explain me through physical nature? What we can identify that? Let us first, what we have to do? We have to divide this entire
Small strip.
into number of small strips. Very, very small strips. Let us assume that the strip of the size is dx and then the vertical ordinate is y. This should be very, very, very small, isn't it?
Yes, sir.
Then what we can say, whatever the area of this single strip, we can identify it as a y into dx.
Y into dx.
Dx is very large. If dx is very large, can you treat this as a rectangle? It's not. Why? Because the shape will matter, obviously. So this formulation y into dx is only possible when your dx is very, very small. Then only you can say that the area of this strip is y into dx. So like that, you have to divide entire curve. And if you want to find the total area, what you have to do? You have to submit all those values yi into dxi. This is what if you write it in terms of summation. If you want to write it in terms of integration, continuous form, we will use the integration y times dx, isn't it? So this is
Yes,
how
sir.
the basic application of the integration. So just like the same thing, if we are having the point load P, then what we are taking, if it is ideal, we are taking the corresponding ordinate, let us say corresponding ordinate is y. But instead what we are having, instead of point load, we are having some uniformly distributed load. Then in that case, how do we gonna solve it? Again, what we have to do, consider the small strip. Let us say the small strip is dx. That means what is the ordinate for the small strip? Y into P. Like that, we have to integrate over the entire length from here to here. So if it is a point load, directly we can take the ordinate. If it is a UDL over the beam, then what we should do? We have to take the area under the curve. So this is what the difference that it will make in comparison to the point load and the UDL. If it is a point load, directly we will take the ordinate under that point. If it is a UDL, we have to take area under the curve, isn't it? Now, let us say, in like, if you imagine, if you compare with the previous case, it's just a point load, that's why we have directly placed at 0.6. Now, can you tell me, if I want to get the positive shear force, maximum positive shear force, where should I place this? Do I have to place somewhere here? Or do I have to somewhere here? Which one you will suggest?
Sir.
Yeah, please. Did I miss something?
The tail should touch.
What is our main motive? Maximum positive shear force, right? If you look at the ILD, if you want the positive values, the first thing is that I should place my load on the positive side only. Do you guys agree with that? What happens if I place my load
Yes,
here?
sir.
Do I get any positive shear force?
Yes.
If I place my load somewhere here, do I get the positive shear force? No, what I'm getting? Negative shear force, right? What if I place my load somewhere here? What will happen?
Will get distributed, sir.
Equally shares both negative and positive.
Let us say positive and negative both will be there. Let us say positive is coming plus 10, negative is coming minus 10. Then what is the net value you talk about?
Yes.
0. That means
0.
if you use this, again, it's not the maximum value. Why? Because positive values will be suppressed by the
Yes, sir. Yes.
negative values. So, if you want to get the maximum positive shear force, you have to place your ideal
Should place
should be on the which side? Positive side, isn't it?
right side.
Now,
Yes, sir.
positive side is okay. Now the next point is, do we have to, in this case, let us say this is exactly 3 meter. Let us say this is a 2 meter. Imagine. Do I have to place my load somewhere here? Do I have to place my load somewhere in this like this? What is the difference between this first case and this second case? Let us say in the first case, this is what the area under the curve. In the second case, this is what the area under the curve. Now look at the curves and can you tell me where we have the larger area concentrated? Under the first or under the second position?
Under first, sir.
First thing is that if you want to get the positive shear force, you have to place your load on which side? Positive side.
Positive.
Second case, when you will get the maximum value? When you will have the higher
Area, more
ordinates.
area.
Yeah, if it is a point load, higher ordinate. If it is a UDL, you have to place it on a higher area. So
Area.
you have to compare such that where you will have the largest area. So in this case, if I place my load along the first case, then only I will have the larger area under the curve. That's why if I want to find out the maximum positive shear force, where I will place the load, I will place my load like this. Is it clear why I have placed there only?
Yes, sir.
Now, this ordinate we know. What is this ordinate? 0.6. Now, what about this ordinate? From here to here, what is the length?
3 meters.
What is the total length of the UDL? Now I'm changing it as 2. 2 meters.
2, sorry, sir.
Just for the simplified case, let us still consider it as only 1. 1 meter. And what about this ordinate? And you are taking the slope here. That means you have to consider this distance. What is this distance? Total from here to here, 3. 3 minus 1, 2. What about this ordinate then? 2 into 1 by 5. How much? 0.4. Now what about the area? It is like a V shape, trapezoid, right? What is the shape here? Positive shear force. What is the formula? Area under the curve. What is the formula for area under this curve? The average of 2 ordinates. What is the average of 2 ordinates? 0.6 plus 0.4 divided by 2 into what is the length between these 2 ordinates? 1 into what is the unit of UDL? 5 kilonewton per meter into 5. So how much you will getting? 0.6 plus 0.4? 1, right? 1 by 2, 0.5. 0.5 into 5. That means 2.5 kilonewton. Any doubt here?
Yes.
Clear, right? Now, again, if I want to find out the negative shear force, then if you want to find out the negative shear force, where I have to place? Let us say this is X, this is Y. Can you tell me if I want to find out the negative shear force, can you tell me starting point or ending point?
Why should be
It should be exactly at C, sir.
Y should be exactly at C. Why?
Because area under that point will be
Yeah.
more under that curve.
If I place X such that if I place like this, the area under this curve is less. So always you have to place
Yes.
the load in such a way that larger area. So the larger area will be possible only if I place the load somewhere here. So this is what the point X, this is what the point Y, and the length between is 1 meter. This is what for negative shear force. Now similarly, corresponding ordinates we have to find it out. This ordinate we already know 0.4. What about this ordinate? What about the total length from here to here? 2 meters. From here to here, how much? 1. Now, what about from here to here? 1 meter. So, what about this ordinate now? What about this ordinate? Can you please tell me? Come on, guys, quick. If you're not saying quickly, then means you guys are not following. That's what I should assume.
0.2, sir.
Yeah, this is 1 meter and slope is 1 by 5, 0.2. Now, what about the area under this curve?
Trapezium.
0.2, 1 ordinate less 0.4, another ordinate by
Divided by
2.
2.
Into what about the distance between them?
1.
Into what is the UDL? 5.
5.
That will be equal to 0.6 by 3. How much? Sorry, 0.6 by 2, 0.3. 0.3 into 5.
1.5.
0.5 kilonewton. So this is what the maximum negative shear force, and this is what the maximum positive shear force. Now, let's come to maximum bending moment. In the previous case, we have only one point load. As there is only one point load, what you guys did is that directly you have placed somewhere here. Instead, it is a UDL. Now, can you tell me how can I or how should I place this load on the beam? Definitely, I will give you two options. Okay, this is what my first option. This is what my second option, and this is what my third option. What do you think? Which one you will choose?
Center ones.
This is first case. This is second case. This is third case. Which one you think will give us the maximum value? First one, second one, and third one.
Second one, sir.
Somebody said second one, and what about others? Second one. Why not first one and third one?
Areas less.
Even in area under
Second
1,
one.
area under 3, area will be lesser. That's why obviously we have to go for second case. But what about their starting and ending points? The total length I know, isn't it? Let's represent here. Total length of the UDL I know 1 meter. But from the center point, from here to here, what is the distance I should consider? From here to here, how much distance I should consider?
0.5, 0.5, sir.
When you should say 0.5 and 0.5? When you have to say 0.5, 0.5 only when, again that if this slope and if this slope is equal, then only you can say it should be 0.5 and 0.5. What if the case is like this? Still will you say 0.5 and 0.5?
No, sir.
In one case, the slopes are equal, 0.5 and 0. In one case, this is lesser slope and this is higher slope. Still will you say 0.5 and 0.5? Obviously, by common sense, we can say, right? It's not. So, even if it is a UDL case, then at what distance? We know that we have to place it at the somewhere in second position, but exactly we don't know. What about the distance from that point, isn't it? Is it clear? What are the question marks that I have made as of now in this case? But for positive shear force and negative shear force, it is clear. But for
Clear,
maximum
sir.
bending moment,
Yes, sir.
we will not get it directly. Okay, now let me tell you one more case. I'm just explaining this one example only. So if you guys need with another examples, you can ask me. But for the understanding, I think one example problem is fine. Okay. Now let us say that the load is having a length of 6 meters. Imagine that it is moving from left to right. You guys are following, isn't it? As of now,
Yes,
no
sir.
doubts, right?
Clear, sir.
Clear? Now, here let me talk about two cases. First case I'm talking about same load, let us say 10 kilonewton per meter. The length of this is 6 meter. Point is XY. Moving from left to right. And in another case, the same UDL is moving from right to left. Now, if I want to get the maximum positive shear force, can you tell me where should I place my load? For getting maximum positive shear force, where should I place my load?
What's right, sir?
For this is what let us say first, this is what let us say second case. Same example. For getting maximum positive shear force, in first case, where should I place my load? In second case, where should I place my load? Think about it. Did you understood this case? This case, is it clear?
Yes, sir. Yes, sir. Clear, sir.
It's like the same thing that I have given you. Think about it and tell me.
Yes, sir. For
If you
first
get a
case,
maximum
X should be exactly at C.
it should be at
Exactly at C.
match with this
X
point.
point.
Tell me the location of X and Y.
Yes, sir. X should be exactly at C, sir.
X should be exactly at C. If X is matching with exactly C, what is happening? Total length is 3 meter. Total length of the UDL is 6 meter. But how much portion we have to consider on the beam?
Only 3 meters, sir.
Yeah, even though the length of the UDL is more than the beam or more than this 3 meter, how much length of the UDL is covering?
3 meter.
3
Meter only, right? So this is what your point X. So this entire part is coming into the picture, isn't it?
Yes, sir.
Now what about that area? As it is a triangle, half into what is the ordinate? 0.6 into what is the length? 3 into what is the ordinate? 10 kilometers. So it is on
Right.
0.3 into 399. So what about from left to right? If it is moving from right to left, where we should place it?
Why should touch C point, sir?
If it is a UDL, for just confusion, I have given you one case from left to right and from right to left. But as it is a
Same.
UDL, it doesn't matter whether it's from right to left or right to left or left to right. Just to confuse, I have given this. But if it is a series of point loads, it's not the same. That we'll discuss in the couple of minutes. Now, for maximum negative shear force, what should be my position of load?
Why should touch C?
Y should touch C, isn't it? So again, this is what your position of the load, but how much length of the UDL is covering the beam?
2 meter.
Even though the length of the UDL is 6 meter, only 2 meter is on the beam. So whatever the area,
Yes, sir.
half into 0.4 into whatever the length of 2 into what is the ordinate? 10.
2
If we
meter.
solve this, how much I'll get? 2
10.
gets cancelled. 4 kilonewton. As of now, it's clear.
Yes, sir.
Now, what about for maximum bending moment? What about for maximum bending moment? What is the difference between previous case and this case? In previous
sir.
case, what is the length of the UDL? 1 meter. But in the present
1
case,
meter,
what is the
sir.
length of the UDL? 6 meters. Now see the length of this span. What is the total length of the beam?
5 meters.
8, sir.
Length of the beam is 5 meter, isn't it? Now,
Yes, sir.
can I simply just place a load like this? My UDL is covering on entire the beam. Why? Because everywhere I am having the positive values, isn't it?
Yes, sir. Yes, sir.
If you look into the previous case, somewhere we are having the positive values, somewhere we are having the negative values. That's why we are making sure that if you want to have the positive values, we have placed load on the positive side. If you want the negative values, we have placed the load on the negative side. What if it is a bending moment? Everywhere we are having the positive values. So what is the worst case? That my UDL load will place entire over the beam. Now it's nothing but what is the area of this entire triangle? Again, half into what is the maximum ordinate? 1.2 into whatever the total length of the beam? 5 into whatever the 10. Then how much it will be?
10.
30 kilonewton. Is it right?
Yes, sir.
Now you can say, in the previous case, why we could not able to find out the maximum bending moment? Because as the length of the UDL is less than the length of the beam, we should know that what is the exact position of the load such that we have to get the maximum bending moment. But in the present case, as the length of the beam is more than, as the UDL length is more than the length of the beam, then we can place our entire load on the beam such that we'll get the maximum bending moment. So what are the cases that we should be thorough about is L represents the length of beam, and let us say L dash represents the length of UDL. Now you can understand one difference, that if the length of the UDL, whether it is less than the length of the beam or more than the length of the beam, did we able to find out the maximum shear force and negative shear force? Even in first case,
Yes, sir.
we found maximum positive and negative, maximum negative shear force. Even in second case, we found maximum positive and maximum negative shear force. That means it doesn't matter whether the length of the UDL is greater than length of the beam or less than length of the beam, but still we can find out what is the maximum positive shear force and what is the negative shear force. Only the problem is with the for finding the maximum bending moment. So here we have to discuss a condition for maximum bending moment. So for that, what is the condition? The first condition I am discussing about, L dash is greater than L. That means what? My length UDL is greater than the length of the beam. If length of the UDL is greater than length of the beam, where we have to place the load? We have to place the load on. Where we have to place the load? See the second case. if the length of the UDL is greater than length of the beam, where we have placed the load? On the entire beam, isn't it?
Section, sir.
So place
Yes,
the
sir.
load on the entire beam. Now, in second case, if your length of the UDL is less than the length of the beam, then this is what the condition you guys have to by heart, that we have to make sure that average load on both sides must be equal. If UDL is more than the length of the beam, there is no problem. Just place the load on over entire beam. Your problem is solved. If your UDL length is less than the length of the beam, you have to by heart this condition. So in this over ideal problems, influence lines diagrams, ILDs, hardly have to by heart 4 to 5 cases. If you can by heart those 4 to 5 cases, then it's of free of marks in our hand. That means the first case is this one. Even if you don't by heart this case, that's even fine. Even for common sense, we can understand this case. But in second case, if your length of the UDL is less than the length of the beam, place the load in such a way that average load on both sides must be equal. Now let us solve that case. Again, we are talking about the same problem. This is point C, this is 2 meter, and this is 3 meter we have considered. And this is what the UDL that we are talking about. Let us say the UDL is, again in the previous case, 5 kilonewton per meter. The length we have discussed is 1 meter. Okay. Now, to get the maximum bending moment, imagine that my load position is like this. Let us say from here to here, the length is A. What about length from here to here? We have to find out maximum point at C. From point C, the starting point of the load is at a distance of A. Can you tell me what is the distance from here to here?
M minus A.
The length 1 meter. So what about this length? 1 minus A. So here I'm talking about a specific case, that's why 1 minus A. Isn't it? Now, what about the, let us say this is A, B. Can you tell me what is the average AC? There are two different parts to get the maximum bending moment. What is the condition? Average load on AC must be equal to average load on CP. Now, how to get the average load? Total load by length of the beam. What is the total load in the span AC? In the span AC, what is the total load? Total load. How to find the total load? What is the length of the portion that it is occupied? A. So what is the total load? What is the intensity? 5. Into what is the portion that it is
Into
occupied?
A.
A. Divided by what about the length of that portion? AC. 2 meter. That will be equal to what is the load magnitude? 5. Similarly, what about the portion that occupied on BC? 1 minus A divided by what is the length of the portion of CP? 3. Is it clear this case how I have written this? Any doubt? Just total load on AC. What is the portion of the load on AC? A into what is the UDL intensity? 5 divided by total length 2. 5 gets cancelled anyway. Now how you will simplify? 3A, that will be equal to 2 minus 2A. That implies how much it will be? 5A will be equal to 2. That implies what is the A value? 2 by 5. That means how much it will be? 0.4. So what about in the first case then? So this is where you have to place your load. So from here to here, what is the distance? Just now we have found it, isn't it? How much? 0.4. So from here to here, it is 0.4. What about from here to here then? Total portion is 1. 1 minus 0.4 is how much? 0.6.
0.6.
Now corresponding to them, what are the ordinates? Okay. What about the ordinate here? Can you tell me? What about the ordinate? First of all, what you should know? We should know this distance. What about this distance? From this point to C, what is the distance to? From here to here, what is the distance? 0.4. That means what about the distance from here to here? 2 minus 0.4, that is 1.6. Then what about this ordinate? What about the slope? 0.6 into 1.6. How much it will be? .96. Is it right? Is it right? 0.96. Guys, please tell me the calculus part because I'm just giving the values randomly. So please do the necessary part. Yeah, 0. Now, this ordinate we already know, 1.2. What about this ordinate then? Quickly, can you find out? .56. Now, what about the maximum bending moment then? Area under this curve. So what about the area under this curve? There are two trapezoids, right? First trapezoid and let us say second trapezoid. What is the area of this trapezoid? First trapezoid and second trapezoid. That will be equal to, what is the ordinate here? 0.96 plus whatever the ordinate here, 1.2 by 2 into how much it will be? What is the ordinate? 0.4 plus whatever the area of the second trapezoid. Ordinate is 1.2 plus whatever this ordinate 0.56 or 5? 56. 1.2 plus 0.56 divided by 2 times whatever the length 0.6. Overall, we have to multiply with what is the load intensity? Load intensity is 5. Overall multiplied by 5. Can you tell me how much we'll get? Is it okay how we have written this equation? Just we have taken area of the first trapezoid, area of the second trapezoid, and then we have added the both, and then overall multiply by the UDL intensity. That's it. This is the area of the first, this is the area of the second, both are added, and overall multiply by the UDL intensity. That's it. Can you please tell me how much you're getting? In this problem, any doubt, can you please let me know kindly? Any doubt as of now? These are the cases that we have to by heart. That's it, nothing else. Only the thing is average load on AC must be equal to average load on BC. That's what you guys have to. Until and unless you tell me the value, I can't go further. Overall 0.96. That's it. Very less. Can others please confirm whether we are getting 0.96 in total or not? Guys, please be active. If you guys have any queries, let me know. You guys have to do the calculation part. Ramya, Pridarshini, and I'll need the values, please. How much? Is it 0.96 or other than that? Vishnu, once please cross verify whether it is right or
6.56.
same only. And others are saying 6.56.
Calculating, sir.
Yeah, please. It's around 2.
The first magnitude 0.96 plus 1.2 by 2.
It is 4.8 kilonewton meters, sir.
4 point?
So totally
4.8.
sir. Is right. 4.8. Magnitude is 4.8 kilonewton meter. I think he's not multiplied with the magnitude of loads.
Have you multiplied with 5, Vishnu? Intensity. UDL intensity, have you multiplied with 5? Yeah, just like as I was saying, if you multiply by 5, then you will get the same answer. So tell me, have you
He
multiplied
didn't
with 5?
multiply. Without multiplication, the magnitude is coming 0.96.
Don't forget those, don't commit those types of mistakes, please. If it is a UDL, always remember you have to multiply with the load intensity. Definitely 0.96 will be there in the options. Or even you, nowadays, you have to enter the answer only, isn't it? If you directly enter 0.96, then even though your problem is right, you might not get any marks. So please don't commit these mistakes. So for UDL case, it's clear, isn't it? No ambiguity for UDL.
Yes, sir.
Only one case you have to by heart, isn't it? One is average load AC must be equal to average load on C. Now, again, let us say we are talking about the same case, 2 meter, 3 meter. Yes, we are talking about the same case so that we can apply it on the other cases too. So I'm just redrawing these diagrams again, as you guys still aware of it. By the end of this course, you guys very much comfortable to the essay. You should not at all frighten about this course. So this is the ILD for shear force at C, and this is the ILD for bending moment at C. Now, tell me, in the first case, imagine the load is moving from left to right, and in the second case, the load is moving from right to left. Seriously, will it be the same or different? If the load is moving from right to left, or if the load is moving from left to right, will it make a difference or no?
Yes, sir.
Obviously, isn't it?
It's difficult.
Imagine, let us say if it is moving from left to right. In first case, if 6 is at 5 kilonewton at point C, how the loads will look like? Forgot about the distances, but as of now, let me write 6, 5, 1. This is what if we are moving from left to right. If they are moving from right to left, then which one will be leading? Which force is leading in this case?
1 kilonewton.
Leading force is nothing but which one is first comes? 6, right? Leading force. If these loads are moving from left to right, which one is leading? What is the first load that will move?
6, sir. 6, sir.
Right? Even if it is moving from right to left, which one will move first? 6 only, isn't it? It's not like 1, it's like so if it is moving from right to left, then if 6 is placed on this here. Now did you identify the difference? This is 6, 5, 1. If it is moving from right to left, 6, 5, 1. Are the position on the same or are they be different? If they are moving from left to right, see, this is what the position of the loading on the beam. If they are moving from right to left, this is what the position of the loading on the beam. So it's kind of obvious that if they are moving from right to left or if they are moving from left to right, the position of the loading is different. So they both will not be the same. That's why in question, you have to clearly that in which direction they are mentioning, whether from left to right or whether from right. This makes huge difference. So is it clear? The direction matters a lot. Once again, I'm saying the direction matters a lot. Now, let's come to the topic. In the first case, I have to find out maximum positive shear. Okay. Now, how do I have to place the loading? Can you give me some idea? If I want to get the maximum positive shear force, how should I place the load? Just for the simplicity, let me assume that this is 1 meter and this is 1 meter, so that all loads will act on the beam. First of all, where the loads should act on, let us say this point is, as we already discussed, ABC. Let us say this is Y, Z. Imagine where should I place my loads on? Will it be on the span CB or will it be on the span AC?
Span CB, sir.
Span CB. Why? Because what I'm interested in?
Positive shear
I'm
force.
interested in a positive shear force. That's why all my loading should be on the right. So let us try to identify the position. What are the possibilities that we can get? What are the possibilities? There is one possibility is that if there is a 6 kilonewton acting on the beam, or 6 kilonewton is acting exactly at the point C, whatever the position of the other loads. If 6 kilonewton is acting on the beam, whatever the position of the other loads, where the 5 kilonewton is situated at?
1 meter.
5 kilonewton, whatever the distance between them, 1 meter. And one is it right?
No, sir.
Instead of 1, let us say it is a, just for the sake I'm writing, there is no hot and cold. Let us say 4. Isn't right the position of the loads?
No, sir.
Sir.
Why?
It will give negative shear, sir.
Yeah, even though it is a negative shear, but 6 I am placing just to the right of C. 6 I am acting at just to the right of C. Can't I place? Why? Because I am taking about ordinate 0.6. 0.6 is a larger magnitude. if I place a maximum load over there, can't I get maximum positive shear force?
But the other two loads are not acting there, sir.
Yeah, other two loads are not on the positive side, they are the negative side.
Side.
So that's what we have to concern about. That if there are series of point loads, unlike the point load, not position, what we have to do is that we have to see the various possibilities and then we have to pick up the maximum value. So this is what one possibility, that I am placing 6 kilonewton at point C. Why? Because 0.6 is the larger magnitude. And what I'm thinking is that if I place my maximum load on 0.6, I might get the maximum. Even it might be wrong. Why? Because other two loads are going on the negative side. Instead, whatever the other possibility, can you tell me?
Placing 4 kilonewton at C, sir.
4 at C, sir.
Even 5 at C2. So let's go one by one and let's discuss. And in other case, what I'm doing, I'm placing 5 kilonewton to the right of C, and where about my 6 kilonewton load? It will let somewhere here. And what about the 4 kilonewton load? It will let somewhere here. What about the distance between them? 1 meter, 1 meter. Similarly, what about the another possibility? 4 I can place exactly at the maximum. And what about the remaining? This is what the 6 kilonewton, 5 kilonewton, 4 kilonewton, 1 meter, 1 meter. Is it right? Other than these three possibilities, is there any possibility that I should check on?
No, sir.
No, right? Everybody will agree to this. So if there are series of loads, we have to see the possible combinations where we can get the maximum values. So in this case, what I have been doing is that I am placing the every load at the maximum ordinate such that I might get some possibility. Now, quickly tell me, what about the values if I solve this case? What about the ordinate under 6 kilonewton? What is the ordinate under 6 kilonewton?
0.6.
6 into 0.6 plus what about the ordinate under 5 kilonewton? It is somewhere here. What about this ordinate? If I am in your place, I can directly say that. What is this distance? 1 meter. What is this distance? 1 meter. It is exactly at the middle. If it is exactly at the middle, what is the ordinate there?
0.2.
What total ordinate 0.4, that ordinate is 0.2. As it is on the negative side, minus 0.2 plus whatever the ordinate under 4.
0, sir.
0, it is exactly at 0.8. So how much you are getting? 6 into 0.6, 3.6. 3.6 minus 1.
1. 2.6.
Isn't it?
Yes, sir.
Now come to this case. Now quickly, what about the ordinate under 4 kilonewton? Exactly, it is same somewhere here, isn't it? You guys have to say me the quickly ordinate values. So what is the ordinate under 4 kilonewton? 4 into
0.2.
how much? Point 2 plus what is the ordinate under 5?
0.6.
What is the ordinate under 6? What is this distance? 1 meter. Then what is this distance? 2 meter. What about the slope here? Slope of the shear force. 1 by length of the beam, 5. Then what about this ordinate? If you guys don't say ordinates, I don't think I should prolong it. Except Vishnu. Ramya and Priyadarshini and
0.4, sir.
how much? 0. So how much you're getting if you're adding these values? How much you get if you add these values? Minus 0.8 plus 3, 2.2, 2.2 and come on, final value please.
4.6.
4.6. Now similarly, come to this case, whatever the ordinate under 4 in the last case, 4 into
0.6.
4 into 0.6 plus what is the ordinate under 5? 5 and 6 they are under same ordinate in the third case and the previous case.
0.4.
What is the ordinate under 3?
0.0.
Ordinate under 6. It's not 0.
Sorry, sir. Okay, sir.
1 meter and 1 meter. Total how much? 2 meter. From here to here, how much? 2 meter. From here to here, 1 meter. Still 1 meter is left. So what about this ordinate? Ordinates
0.2.
0.2. Now in total, how much you are getting?
Five 5.6.
5.6. Right now, tell me in Y case 3, we are having value, and in case 1, why we are having the negative value?
Sir, in third case, all the 3 values are under positive shade, sir.
Okay. And in first case?
In the first case, only 2 is in negative, 1 is in positive, sir.
Yeah. And any other reason that we can come across? See, instead of 4, 5, 6, if I place 1, 1, 2, 2, 1, 1 different kind of positions, do you think in third case only I will get the maximum value in all the possibilities? So in this case, 3 logics that we have to understand. First logic is that even though maximum is under the maximum ordinate, we will not get the maximum value. Why? Because what about the other 2 loads? They are going into the
Negative side.
So even though you are placing the maximum load directly under the maximum ordinate, still you may not get the maximum. Because as some loads are moving on to the negative value, it might not give us the maximum values. Now, one question I will ask you. In first case, what is the ordinate of maximum load? What is the ordinate of maximum load?
0.6.
0.6. In second case, what is the ordinate of maximum load? In the second
Point
case, what is the
4.
ordinate of 0.4? In the third case, what is the ordinate of maximum load?
0.2, sir.
That means what is happening? The ordinate is decreasing. Similarly, the contribution is also decreasing, isn't it? So, in this case, as your loads are moving to the zero value side, what is happening? Your values are decreasing. As your ordinates are decreasing, in every possibility, this third case also may not yield the maximum value. Luckily, in this case, we have got the maximum value, but every time it is not sure that if you place all the loads on the positive side, you will get the maximum positive shear force. No, that is also wrong. Only the thing that in our hand is that every time we have to look at on all possibilities and pick up the maximum value. Is it okay now? Any doubt in these three cases? Any doubt as of now? If there are series of point loads, is it clear that maximum positive shear force? The same thing is for negative shear force too. Or can you quickly solve what is the maximum negative shear force that you can get? Can you guys quickly tell what is the maximum negative shear force if the loads are moving from left to right? Can you please tell me this value quickly? Please find it out quickly. Meanwhile, you guys are having any doubts, let me know. It won't take not more than 5 minutes. Please tell me the value. What is the ordinate of maximum negative shear force? You guys find it out, and meanwhile, those who are having doubts, let me know. I will clarify it. After that, we'll go to the cases for maximum bending moment.
Sir, for each cases, we have to find these type of arrangements, sir.
For
Each and
sorry, Ma, you are not clear. Can you please come again, please? Vishnu, don't give quick answers. Very much quicker. Can you please repeat your question, please, or can you please type it?
yes, sir.
I need the answer, please. Vishnu, if you found it, please verify one more time and let me know. For each and every case, we should consider, yeah, we have to, there is no option left. It just comes from the practice only. And that's why if it is a series of point loads, in exam, they won't give not more than 3. In worst case, not more than 4. Not at all. In worst case. One more answer from Vishnu. Okay, two more cases that we have to complete today regarding the bending moment. So please be hurry up. Or at least if I can receive response from any one more person, then that will be great.
3.4, sir.
3.4. Vishnu, you got 3 in one case, 2.6 in one case, but somebody is getting 3.6. So you guys have to verify. Let me see. Let me get response from 3 more. What about other 2? Let me hear your response. Yes, Ramya.
I'm working out, sir.
Yeah, please. Don't worry. Take 4 more minutes. At least, are you guys got an idea how? Haven't received any response. If you guys are not solving, then we'll move on to the another case. We don't waste time. How many cases you guys have solved at least? Can I make it as a homework so that can I discuss it on the next class? If you guys are unable to match your answers, we'll discuss on the next class.
Okay, sir.
Yes. In the same way, so for this loading, you guys have to find out maximum positive shear force, maximum negative shear force, if the loads are moving from left to right, and also if the loads are moving from right to left. Is it okay? At the same time, you guys have to find out what is the maximum reaction at A. At the same time, you guys have to find out maximum reaction at B. Now you have to ask me that, as we haven't discussed for reactions, how can we solve it? Just with the same logic that you try to apply it for 3 different types of cases, then obviously you'll get it. Just for again trial and error only. Whatever the logic that you guys are applying, the same logic will be applicable for the reaction forces also. Clear?
Yes, sir.
Okay, now let's talk about for maximum bending moment. Maximum bending moment at point C. 4, 5, 6. Again, in general, by looking at this ILD diagram and look at the loading diagram and tell me how I should place the load such that I should get the maximum bending moment. This is what ILD for bending moment at point C. Let me, please do me the first thought after you looking at this diagram and looking at this type of load, where we have to place the loading. Do you guys have any thoughts? What point should coincide with which one? Looking at the diagram ILD and looking at the loading diagram and tell me what might be the possibility. Again, if I talk about where should I place the loading such that I should get the maximum ordinate. If I place the maximum load 6 kilonewton here, again there is a possibility. If I place a 6 kilonewton here, 5 kilonewton might place here, 1 kilonewton might place here. This is one possibility. Sorry, 4. If I place 5 kilonewton over here, then 6 kilonewton will lie somewhere here, and then 4 kilonewton will act here. If I place 4 exactly at point C, again this one will be the position of 5 and this one will be position of 6. Again I should sort out for these three different types of cases. Now, in general, look at these forces and look at the ILD diagram. What do you think? Which one might give the maximum value? In this case, I can tell you directly, at least in a generic way.
So the maximum load,
Number two, sir.
Number two, number one, or number three?
Number two, sir.
Why? Because what is the reason that you guys will judge it?
Area is more.
Vishnu, I think one I can directly wipe it out, or I don't know why, because if I look at the ordinate of 4 kilonewton, it is 0. So that's why this ordinate will not acting directly. And even if I look at the possibility of 3, what about the ordinates of 5 and 6? Are they decreasing or the maximum?
increasing, sir.
If the loads are moving towards zero slope, then what is happening? Obviously, the ordinates of those points will decrease.
Decrease.
So you can think that in general, if I am at your position, I should think that 2 might give the maximum value. I might, again I'm saying I might. Yeah, as per you, maximum bending moment under maximum load, but at the same time 4 is not contributing anything. Why? Because what is the ordinate there? 0. 1 or might not be. So the condition, the same condition we can apply it for UDL. What is the condition for we have applied for UDL? At any point load, we have discussed one thing. What is it? Average load on AC must be equal to average load on CP, right? If it is a UDL, as it is a continuous, then we can say that, okay, directly we can find out the position. But as these are concentrated loads, exactly these values might not be equal. As these values might not be equal, we have to take the appropriate range. Let me tell you how. Let us say on the first case, I'm taking average load on AC. In the second case, I'm talking about average load on BC. Average load on CB. And then I'm talking about net value, the difference of these two, or let's say. Imagine if 6 kilonewton passes point C. If 6 kilonewton passes point C, that means how many loads will be there on span AC?
2, sir.
2. And how many loads will be there on CB?
Load.
Right? What is the average load on AC then?
5,
4,
sir.
5. Total 4 loads will, 2 loads will be there, right? In the AC.
Yes, sir. Yes.
4 plus 5 divided by what is the length? 2. What is the ratio? 9 by 2. How much it will be?
4.5.
4.5. What is the average load on CB? If 6 kilonewton is crossed point C, how many loads will be there at CB? Only 6. 6 by 3. That will be equal to
2, sir.
Are they equal? No, isn't
Not
it?
equal.
What happens if 5 kilonewton passes?
One load will be on
Only
AC.
one load will be there in AC, that is 4 by 2. That will be equal to 2. Whatever the average load on CB? 5 plus 6, 11. 11 by 3. How much it will be?
3.66.
3.66, right? So what about the net value here? Let us find out average load on AC minus average load on CB. Here it will be the negative value, isn't it? Or positive value. 4.5 minus 2 is greater than 0. In this case, what is happening? 2 minus 3.66 less than 0. At which point transition is occurring? That means it is transitioning from one side to the another side. If 6 kilonewton passes C, we see that average load on AC is greater than average load on CB. If 5 kilonewton passes, average load on AC will be less than average load on CB. That means if 5 kilonewton passes the point C, the transition is happening. Here we are not exactly getting equal to 0. Why? Because if it is a UDL, we will get exactly equal to 0. But as it is not an UDL, you have to pick the transition point. What is the transition point? That it has a transition point means one average load will be more beyond the one. In the 6 kilonewton passes, average load on AC is greater. If 5 kilonewton passes, average load on CB is passes. That means this is what the point which is occurring the transition. So if you place the 5 kilonewton load at point C, it might give you the maximum value. But let's see and find out for all these three cases. Before that, let us find out this ordinate. What is the ordinate here? 1 meter, 1 meter. Can you tell me what is the ordinate here?
0.5.
Point
5.
0.5? Are you sure? Is it 0.5?
No, sir.
Somebody
One, sir. One, sir.
ordinate.
The point 1.2 by 2, 0.68.
1.2 by 2. How much? 1.2 by 2.
0.6.
0.6, sir.
1.2 by 2. We should not commit mistake. 0.6. What about this? What about the slope here, first of all? What about the slope for bending moment? Opposite by total length. What is the opposite? 2. By what is the total length of the beam? 5. That will be equal to 0.4. Now tell me, what about this ordinate? From here to here it is 1 meter. From here to here it is 1 meter. From here to here it is 1 meter. What about this ordinate? I don't know why you guys are taking so much time for ordinates.
0.8, sir.
0.8. Yes, thank you. And what about this ordinate?
0.4.
Thank you. Now, for first case, can you tell me what is the maximum bending moment? What is the ordinate for 4?
0.
0, sir.
Plus what is the ordinate for 5?
0.6.
And 6 plus ordinate for 6. How much it will be?
The 10.2.
10.2.
2.
Okay. Unit must and should kilonewton meter. Now what about for second case? What is the ordinate under 4?
0.6.
0.6. What is the ordinate under 5?
1.2.
1.2. What is the ordinate under 6?
0.8.
0.8.
13.2.
13.2. And in third case, what is the ordinate under 4?
1.2.
1.2, sir.
Ordinate
The
under
4 into
4.
1.2. 5
Ordinate
into
under
0.8. 6 into 0.4. 11.2.
11.6.
2.
2.
Now is it satisfied or not? Second case, as we have discussed that wherever the transition is happening, if you keep that load on that point, then you will get the maximum bending moment. This case is also same to the previous like UDL load, isn't it? Have you done anything differently? No, but what is the difference? If it is a UDL load, we can find out the position of the loading exactly on what point the average load on both spans are equal. But if these are the concentrated loads, we cannot exactly find out the position where they are exactly equal. Instead, what we have to do is that we have to take the load where the transition is happening. That load we have to keep it at point C. Then we will get the maximum value. So this is what the condition for maximum bending moment at point C. Clear? This case too?
Yes, sir.
Sir,
All these cases you guys have to by heart. There is no option left for you. Yes, please.
sir, can you go to the previous slide, sir?
Yes.
Sir, if the load is suppose 4, 6, and 5, should we interchange the load order, sir, or should we take as it, sir?
Can you tell me once again? Load?
Here the loading is 4, 5, 6, sir.
Yeah.
In case if it is 4, 6, 5, or in case if some other value is given,
Yeah, please find out accordingly. No
should
option
we
left.
interchange the value, sir?
Should we?
Interchange the value in ascending order or descending order?
Yeah, interchange the value and see how they are gonna changing. That you can do it as a homework too, if you wish to. And there are a lot of possibilities, isn't it? It's not about loads only. 4, 5, 6. Even it matters for this distance, isn't it?
Yes, sir. Yes, sir.
Even it matters with the distance of the limb. So these are the factors. What are the factors? The sequence of the load, the distance between the loads, the distance at what point you are finding on the for bending moment. So these are so many factors that will affect. So if you even interchange the loads and see how they are going to affect it. Clear? Shall we move on to the next case? What is the difference between the previous case and the present case? What is the difference between absolute maximum bending moment? What is the difference between maximum bending moment at point C? Can you justify the difference between these two? Maximum bending moment at point C and then absolute bending moment. By the name itself, what you are going to get it?
Only the positive value, sir.
It's not about positive value. If I am talking about maximum bending moment at point C, that means we are finding the what is the maximum value at point C. But if I am talking about absolute maximum, that means over the entire beam. It is not specifically at the particular point. Over the entire beam, if the loads are moving on the beam, what is the maximum bending moment that you will get it? Is it clear? Let us say, let me tell you one example. The same example, and let us say the same load. In the first case, what I'm talking about? I'm talking about maximum bending moment at C only. But in the second case, I am talking about maximum bending moment. That means in the second, here it is clear. If the loads are moving over the beam, at point C, how they are changing. After those values, we are talking about the maximum value. If it is the absolute maximum, that means we are talking about the entire beam. On the entire beam, what is the maximum bending moment that is possible if the loads are moving? Here we are not specifically talking about a point. Either we are not talking about point C or not talking about point. Over the entire beam, what are the maximum values that can be possible? For this again there is one condition that you have to by heart it. Let me discuss the condition. If it is a maximum bending moment at any particular point, how we have to find out? You have to find out a transition point where the average load on AC and average load on CB. Let us assume that there are 4 point loads. Let us say point load 1, point load 2, point load 3, point load 4. Let us assume that these point loads are moving over the simply supported beam, and then I am interested in what is the maximum bending moment over entire beam, not at a particular point. If I take each and every point of bending moment, each and at every point, what is the maximum value that I am getting? For that, the condition is like, first we have to find out the resultant of these forces. Let us assume that the resultant is finding somewhere here. Let us find out that resultant is finding, or resultant of these 4 loads is somewhere here. And let us assume that this distance is come as 1 meter and distance you have come as 2 meter. Can you tell me what is the adjacent load to the resultant? To this
P2.
specific case, P2, right? Whichever is nearer to the resultant, that is what the adjacent load. So the adjacent load here is nothing but a P2. So whatever the load that is nearer to the R, that is what the nearest load, or we can say it is a adjacent load. Now, after finding out the resultant and after finding out the adjacent load, what we have to do is that first find out the center point of the beam. So whatever this length, if total length of the beam is L by 2, this one is L by 2, and this distance is L by 2. Now what you have to do is that place P2 and R in such a way that it should be equal distance from the centroid. After finding the centroid, place the load P2 and resultant in such a way that they will be at equidistance from the centroid. That means imagine that this is what my load P2 and this is what my load resultant, imaginary. How we have to place? You have to place this in an equal distance. Or be X, this should be X. For to the specific case, what about this distance then? 0.51, 0.5. For the specific case, 0.51, 0.5. Can't I know, or can't I find the position of the remaining loads? P1,
Yes, sir.
P3, P4. What is the first point? You have to find the resultant. First point is you have to find out the resultant, and what about the how to find out the adjacent load? How you will define the adjacent load?
It is nearer to the resultant.
Nearer to the resultant. And third point, how we have to place?
Equidistant from the center.
Place the load such that resultant I am representing with R, adjacent load I am representing with A. So R and A should be
Equidistance.
equidistant from centroid. Sorry for my handwriting, I'm very bad at handwriting. Okay, now point under the resultant or point under the adjacent load, we will have the maximum bending moment. That means at this section we have to draw the ILD for bending moment. So can we apply this logic for the case that we have discussed? What is the case that we have
The
discussed?
summation, sir.
Sorry?
Resultant is just the summation of all the 4 forces.
Is it just the summation or anything else?
I'm not sure, sir.
Just for the some different, let us say 1 meter and 2 meter. How you'll find the resultant? Let us say this is X, Y, Z. Find out the summation of moment at point C, at point X, or any other point. Whatever the summation of points at X, find out the moments at point X. What is the moment due to 4 kilonewton?
0, sir. 5
0,
into 1.
5 into 1,
2.
6 into 3.
5 into 1 plus
6
6
into
into
3.
3.
what is the value? 5 plus 18, 23.
18.
These are the nothing but a
23.
resultant moment due to applied forces, right? Now let us imagine that your resultant is falling somewhere here. And let us imagine that it is at a distance of capital X from X. Now what about the moment at point X due to the resultant? R times the X, isn't it? What about the total resultant value? If you had all these values, how much you should get? That is what your resultant force. What is the resultant? 4 plus 5, 9. 9 plus 6, 15. That will be equal to 15x. Now, what is unknown value? X. So how can I find it out? X, that will be equal to total net movement is 23 divided by 15. How much you are getting?
1.53.
1.53.
53.
Yes, Vishnu. Yeah. Now here, so what is the resultant? Resultant is falling somewhere around here. And what about from here to here distance? 1.53, right? Now that means from here to here, what is the distance? From here, X to Y, what is the distance? 1.
0.53.
Resultant, what is the distance? 0.53. Now tell me which load is nearer? 5 kilonewton or 6 kilonewton?
5 kilonewton, sir.
5 kilonewton to resultant, what is the distance? 0.53. From
0.53.
R to the R to the 6, how much distance? 2 minus 0.53, isn't it? So which is nearer? I can say that 5 kilonewton is nearer. Now what I should do? I'll take the beam. What is the length of the beam?
3 meters.
Total length of the beam, 5 meters, isn't it? Total length of the beam. From here to here, 2.5.
Yes, sir.
And from here to here, 2.5. How we have to place? Adjacent load and resultant should be equidistant, isn't it? Now, imagine this is what your adjacent load. What is adjacent load? 5 kilonewtons that I am squaring it. And what is the resultant? Resultant load is somewhere here. What is the distance between them? 5 kilonewton to the R.
0.53.
0.53. Half of them is how much?
0.265.
0.265.
0.265. Right? This is what the center point, isn't it? Now, now can you tell me what is this distance? Can I find this distance or not? From one end to the 5 kilonewton load position?
Yes, sir.
2.235.
2.5 minus
From here to here, 2.5. So what about this distance will be? 2.5 minus 0.265. How much it will be? 2.35.
2.235.
Now can I find the remaining position of the loads? 4 kilonewton. And what about this? 6 kilonewton. Can you redraw it in another slide? This is what the beam. Now we know the position of the 5 kilonewton load is how much at a distance of from one end. What is the distance as we found out? 2.265. Based on this, can't I find the position of the other loading? What is this? 4 kilonewton. And what is this? 6 kilonewton. From here to here is how much? 1 meter. From here to here is how much? 2 meter. Now, draw the ILD corresponding to the load 5 kilonewton. Whatever the ILD corresponding to the 5 kilonewton, this load. Whatever this ordinate, can you tell me? dB by L, right? What is the one side distance? 2.265. Whatever the other distance from here to here, what is the distance? Total length is 5. 5 minus 2.265 is how much?
1.236.
Wait. How 1 point? How come? It's not 1 point.
Ordinate is 1.23.
Can you tell me this distance?
Ordinate is 1.23.
Everybody is okay. Not exactly 2.27. Acha, 2.735, right? 2.735. 2.265 times 2.735 divided by total length is how much? 5. So how much we are getting ordinate? 1 point.
236.
1.236. Is it right? Is it okay?
Yes, sir. 1.238. 238, sir.
Yeah. Similarly, you can find out ordinate corresponding to 4, ordinate corresponding to 6. Similarly, you can find out what is the ordinate corresponding to 4, what is the ordinate corresponding to 6. Then can you find out, right, what is the maximum? Quickly, can you tell me these ordinates at least first of all? Is it okay first of all how to find the absolute maximum bending moment?
Yes, sir.
These are the cases we have to by heart it for the exam. There is nothing logical that you should think about here.
But this takes a long time, sir.
If you practice well, I think you can. For 2 marks, itna to this much we have to do.
Okay, sir.
Is it right? This ordinate is 0.23253. Is it right? Guys, what happened? What about this slope that you guys know quickly? What is the opposite distance? 2.735 divided by length is L. Then what about this ordinate then? If I'm treating this as M, what about this ordinate? M into what is the distance? From here to here, what is the distance? 2.265 minus 1, 1.165. How much it will be? 0.69. Then how about this ordinate? What is the slope? What is the opposite distance? 2.265 divided by 5. Let us treat this as N. Then what about this ordinate? n times, what about this distance? Total is from here to here 2.735. So 2.735 minus 2. That will be equal to 0.735. So n times 0.735. How much it is?
0.33.
0.33. Now, what is the absolute maximum bending moment? Ordinate under 4, 4 into 0.69 plus ordinate under 5, 1.236 plus ordinate under 6, 0.33. How much it will be?
$10.9.
10 point.
10.27.
10.27. If the procedure is okay, then I will discuss simply 3 different cases and then we'll wind up today. It won't take not more than 5 minutes. Let's complete this topic and wind it up. If the procedure is okay, can I discuss with 3 different possibility cases that can happen?
Yes, sir, we can.
Yes, sir.
Now, what happens if R means resultant, right? What happens if R and A, they both are coincides? If resultant and adjacent load, they both are coming on the same line, then what will happen? Yes, Vishnu. So imagine there are 3 different loads, let us say P1, P2, P3. Let us say all these are equal forces, 4 kilonewton, 4 kilonewton and 4 kilonewton. And the distance between them is 1 meter. What do you think where the resultant will be in this case?
Center 4.
The distances are equal. Then where the resultant will be? R will be equal to total how much?
Right.
3 4s are 12. Our load is set. What happens? The condition we discussed. Where is the load? We have to place the load in such a way that R and adjacent load should be equidistant from the centroid. If R and adjacent load both are coincides, then at what point we have to find out the maximum bending moment? Exactly at the centroid. L by 2 and L by 2. The P2 should be placed on the centroid. Right? In the previous case, it is not exactly at the centroid. It is at a distance of 0.265 from the centroid. Why? Because resultant and adjacent force both are not coinciding. But in this case, what is happening? Resultant and adjacent, they both are coinciding. If both are coincides, exactly we have to find out at the center point. Is this okay?
Yes, sir.
Now, second case, P1. Again, I am telling you 2 different cases. P3 is equal to 10 kilonewton. P2 is equal to 15 kilonewton. And P1 equal to 10 kilonewton. And imagine that if your resultant is somewhere here, let's say the distance is 0.5 and 1.5. What is the adjacent load that we have to consider?
P2, sir.
P2. Why? Because this is much closer, isn't it?
Yes, sir.
Let me change something. P1 equal to 10 kilonewton, and in the second case P2 is equal to 5 kilonewton, and in the third case P3 is equal to 20 kilonewton. And again the resultant is falling somewhere here. Again the distance is 0.5 and 1.5. What is the incident load that we have to consider in this case? What is the in the first case, the distance is PT is lesser. Even in the second case, the PT is less. But what is the difference? What is the other load? 20 kilonewton. But in the second case, what is the other load?
10 kilo.
In the second case, the load corresponding to the adjacent load is higher. But
Yes.
in the third case, what is happening? Is it higher or lesser compared to the other load?
Lesser.
So if the adjacent load is lesser value compared to the other one, in this case, we have to obtain for both cases and then pick the maximum value. Isn't it? That means you have to place adjacent load. First, you have to consider it as the P2. In this case, in the first case, adjacent you have to consider it as a P2, find the maximum value. In the second case, consider adjacent load as a P3, find the maximum, and then pick up the maximum of these two. Why? Because in the third case, even though the resultant is nearer to the 5 kilonewton, but the heavier load is on the other side. That's why find out maximum bending moment by considering both cases and then pick the maximum value. Clear? So these three are the possible cases that we might have encountered while finding the maximum bending moment. As of now, any doubts?
Yes, sir.
And then if you guys are interested, try to solve it for the 4 cases. These values I'm giving it randomly. It might be useful, it might not be useful. 2 kilonewton, 3 kilonewton, 1 kilonewton, 5 kilonewton, 1 meter, 2 meter. Again, consider the same simply supported beam. And let us consider the total length is 20 meter and consider a point C. It is at a distance of, instead of 25, let us consider it at 25. And one is at 10 meter and another is 15 meter. Again, try to find out what is the maximum positive shear force, what is the maximum negative shear force, what is the maximum bending moment at C, and then find out maximum absolute bending moment. And again, if this is A and B, again find out what is the maximum reaction at A, and similarly find out what is the maximum reaction at B. We'll cross verify your answers. If your answers are telling, then we might think that answers is right. If not, then they are wrong. Can you try for this case?
Yes, sir, we can.
In this case, first we should rearrange the load, sir.
Imagine that the loads are moving from right to left to right and left to right. For these 2 cases, please solve it. That means 2 set of values coming. The leading force is 5 kilonewton. Can you tell me what do you mean by rearrangement?
That is the first one is 5, second one should be 3, then the 2 kilonewton, the last one
In the
is 1
exam,
kilonewton, like that.
In the exam, we should not draw like whatever the load case they will give. For that only, please find it out. Don't rearrange them.
Okay, sir. Okay, sir.
Previous, I mean to say that if you change them, the answers might be different. That's what
Okay, sir. Okay, sir. But whatever they are giving, we should take as such.
Yeah. And Vishnu, even for reactions also, what you have to draw the ILD and try to try different trials where you can get the maximum values. Just like the approach we have for the maximum shear force and negative shear force. The same approach you have to follow, nothing else. So as of now, the ILDs successfully we have completed except for the trusses. In the next class, we'll discuss ILD for trusses and then we'll wind up the influence line diagrams. So meanwhile, please solve any problems and then let me know. And Ramya, what are the problems that you have sent me? Hope please solve them again now. Hope you can able to solve it.
Yes.
If, we'll discuss on the next. Okay.
Yes, sir.
Hope it's clear, right? If you guys have any doubts on the influence line diagrams, try to solve it by tomorrow, and then day after tomorrow we'll discuss them in detail if you guys have any doubts. Okay.
Yes, sir.
Okay, guys. Thank you so much.
Thank you,
ILDs
sir.
we have successfully completed. Bye.
Thank you, sir.
Take dinner and rest. Okay, bye. Thank you.
Thank you, sir.